So this one here, arithmetic sequence, how can you tell if something's an arithmetic sequence or not? Goes up by the same amount each time, that same common difference. So this one goes up by 16, 16. How can we figure it out? Term 2 minus term 1, so it's 16. 16 gets me here, 16 gets me here, 16 gets me here, 16 gets me here. So this one has a common difference of 16, so it's arithmetic. This one I do term 2 minus term 1. 4 minus 2 is 2. 8 minus 4 is 4. Ugh, not working. So this one does not have a common difference, so it's not arithmetic. Then I go 7 minus a minus 4. 7 minus a minus 4 is actually what? Speak up when I don't write the right number, because I know that's why yours you do that. Negative 7 minus a minus 4 is what? Negative 3. Thanks, guys. You're so helpful. It makes you sound like you're doing lots of work on here, but in reality, you guys are completely saying nothing. Just putting it on the mic so that you guys know if you listen to this later that you didn't speak up or give any answers whatsoever. You just sat there quietly. All right. So negative 3. Minus 4 minus 3 is minus 7. Minus 3 is negative 10. So we have a difference of negative 3, so it works. And then here we'd go 0 minus a minus 3. So what happens? What's 0 minus a minus 3? It's not a minus 3. My goodness. 0 minus a positive 3, because that is not a sign. That is a dash. Note to self, just in case you all fell to that. I was just seeing if you saw that. No, not so much. 0 minus 3 is negative 3. Negative 3 minus 0 is negative 3. Common difference of negative 3. Woohoo, there's 3 of them. You always fill numeric response in from boxes from left to right. Okay, all the boxes do not need to be filled in, so don't add extra zeros just for fun because you feel like every box needs to have zeros. It does not. You can fill in 1 box, 2 boxes, 3 or 4. The catch on numeric response, you guys, is that there are only decimal spots in the 2 middle boxes. Okay, for your actual exam on the diploma, there's a decimal here and a decimal here. So if it's like decimal 30, you can't go decimal 30. You'd have to go 0 decimal 30. Whenever it's a decimal, you have to start with a 0 because only the 2 middle boxes contain decimals. Okay? Why would the back box not contain a decimal? Because that would be just dumb. Like 200 decimal, like that's just not bad. So it's only in the middle 2. On the test, I'll still get people going decimal 3. If you can't fill in the bubble and you can't find the bubble for a decimal spot, you can't do that, okay? Because on the diploma and on your test, they just literally look at the bubbles and see which ones are filled in, right? There's no person actually looking in the boxes. They're not that nice. They just run it through a machine, and then you look at the decimals. And it just runs through the machine and counts the bubbles. Okay, this one I know a few people probably just did it by mental math. We do not want to just do it by mental math because this is a nice little easy one that you probably could figure out that way. But what if I give you one that's way harder? So remember what I said, if you have a start number and an end number, you can just treat that as its own sequence and get D, right? So we can treat this like it's its own sequence. So term 1 would be 4, and this is just to find D. Term 4, or term N, is 10. Now I can use that to find D. So I go term 4, which is 10, equals term 1, which is 4, minus N. N is 1, 2, 3, 4, because I'm only looking at the 4 numbers, right? 4 minus 1D. Move the 4 over, and I get 6 equals, it's plus, isn't it? 3D. And D equals 2. Now there's a few of you who probably guessed 2, and it worked out for you. But like I said on the test, you're probably going to get some with decimals so that you can't just guess them, okay? So 4 plus 2 is 6, plus 2 is 8, plus 2 is 10, minus 2 for when this direction is 2. So what is my actual T1? My actual T1 is not 4, that's my T2, but I just used it to find my D, right? My actual T1 is 2. So place the answer for T1 in the first numeric response box. Place the answer for D, which is also 2. Are they always the same? No, they just happen to be the same. In the second box, so you'd go 2, 2. Numeric responses can never have negative numbers. So if you get a negative number, you're wrong. Go back, try again. The other way that you could be right is if you get, say you got the common difference was negative 2. What they can do is they can say, put the absolute value of D in the numeric response box. What is the absolute value? It's always positive, because the absolute value is your distance from 0. So -2 is 2 from 0. 2 is 2 from 0. So your absolute value is always positive. So if they get you a negative sign and they want to be able to get you to write it into a numeric response box, they can ask for the absolute value of it, and then it causes it to be turned to being positive. So if they ever ask you for the absolute value of something, there's a hint that it probably turns out to be negative, and they make it absolute so that it goes and you can actually fill it in. Okay? Other than that, if they don't ask for the absolute value of it, your answer can't be negative. Your answer could be negative if they said, say our T1 was -2 and our D was -2, and they told me T1 times D. That could work, because what's T1 times D? It would be -2 times -2, which is +4. So your ultimate answer at the end when you go to fill it into your numeric response box has to be positive. Can the answers along the way be negative? Absolutely. But the moment you go to fill it into the numeric response box, it has to be positive. Okay? So if it's not, go back, try again. So each of those verse 1 mark. Then let's look at this one. Susan joined the fitness class at her local gym. Into her workout, she incorporated a sit-up routine that followed an arithmetic sequence. On the 6th day, so whenever they give me days like this, I draw out my sequence, okay? So 1, 2, 3, 4, 5, 6 days, so T6, there was 11. And then on 15, so 7, 8, 9, 10, 11, 12, 13, 14, 15, T15, there was 29. Now, I can guess D, hopefully, because I picked you nice Ds. But what can I do if I have a start and a finish always? Yeah. Turn T6 into T1, turn T15 into actually to 10, because that's 10 numbers, right? And then find D. So we can go like this. Treat this as T1. Treat this as T10. Please count them if you don't believe me, okay? Why is it 10 and not 9? Because we're including. It's inclusive of T6 and T15. So what we could do is we could go T10, so 29, equals T1 plus n minus 1, so 10 minus 1D. 29 equals 11 plus 9D minus 11. 18 equals 9D. D equals 2. I promise you, if you're someone who doesn't ever use this formula throughout this quiz, you're going to bomb the unit test, because I'm going to force it so that you won't be able to figure them out by just guessing. Or the guessing is going to be so hard that you're going to run out of time and you're not going to be able to answer the test. Why? Because you need to learn how to do it properly. You need to learn how to actually do it sometimes. If you're guessing the odd time and you work through, that's okay. But if every question you never use the formula and you're like literally trying 2 each time, nope, trying 3 each time, nope, trying 4 each time, you will run out of time. Okay? And the diploma is so much so for grade 12 that you won't be able to do that, you guys. They will make it so that you have to understand what you're doing, not just you're guessing the whole way through. Okay? You would run out of time. So please don't, if you just guess the whole way through, see if you can actually figure it out with the math, okay? So we have D equals 2. So it wants the general term. In order to get the general term, I need T1, N stays N, D I need, which I found was 2, and Tn I need. Now I could use the formula to find the actual T1, but because there's so many little ones in front of it, there's not very many, I would just literally just count back. So if I add 2 to get me there, I can subtract 2. So I get 9, 7, 5, 3, 1. So T1 is, 1. So I have Tn equals T1, which is 1, plus n minus 1, and D is 2. I distribute in. So I get Tn equals 1 plus 2n minus 2. Collect like terms, and I get Tn equals 2n. -2 plus 1 is -1. So that's my general term. And once I have my general term, I can answer any question after that. The question after that is, if Susan's goal is to be able to do 100 sit-ups, on which day will she accomplish this? 100 is the last amount, right? The last amount. Whenever it's the last amount, that's your Tn. So we can use our general formula, Tn equals 2n minus 1. And for the most part, I'm expecting that some of you just went 29 plus 2 plus 2 plus 2 plus 2 plus 2, plus 2 and added them and figured out what day that would be. But we want to actually use the math because we have this. So we know that the last amount she wants to do is 100 sit-ups. So we go 100 equals 2n minus 1. Add the 1. We get 101 equals 2n. Divide by 2, and we get 50.5. And you're like, hey, Lepp, you told us yesterday, put a star and say n can never be a decimal, right? It can't be. However, if I round this down to 50, does she do 100 sit-ups? No. If I round it up to 51, does she do at least 100 sit-ups? Yes. Does she do more? Yeah, that's fine, but she needs to do at least 101. So the day that she will reach this is 51. Because at 50, she won't actually have done 100 sit-ups. Okay? Remember, I told you all of this is from your homework. Yeah? On day 50, she would have done 101. Oh, let's think about this. Well, she would have done 99 on day 50, right? Yeah. And then on day 51, she'd do 101. Because on day 50, she would have only done 99. She had to go to 51 to do 101. So technically, she's doing more, but at least she's doing 100. Does that make sense? Okay. Alrighty, so you can put a mark out of 4 on there. And we do so many of these that even if you do poorly on a couple, it may look like, but in the end, they all average out so much so that most people get the full 5% anyways. Because I also put into this the assignments too, right? This 5% is the assignments that you guys do with your book open. So even if the marks are sometimes really good or really bad, they usually balance themselves out because I probably do 40 to 50 things in this one little 5% category. So at the beginning, it seems like a substantial amount, but when you do 50 things, 5%, each thing's worth so tiny, right? Why am I still recording this? Okay, arithmetic series. So we're going to learn series, sequence series. So arithmetic still means that common difference of D. Arithmetic series means we're going to add them up. So there's going to be sums. So if ever it asks for sums, or you have plus or minus signs in between your series, which is actually why it's called a series instead of a sequence, then they're asking you to sum it up. So the moment they say sum, you're going to have to use the sum formulas. It's a huge hint. So whenever you read sum, you're literally going to underline sum and know you need to use the 2 sum formulas. So obviously, I won't do this on the test. Find the sum of the following arithmetic sequence, 3 plus 6 plus 9 plus 12, because what could you do? 3 plus 6 plus 9 plus 12, like really, not going to probably ask that. So would I ask maybe, what's the sum of the first 50 in that series? Yeah. Because then that would at least make you have to push the buttons a lot. At least I have to give your hands a really good workout in order to get the answer if you don't want to use the formula. Okay? So I'm going to at least make you do some sort of amount of enters for a while at least. Okay. So the thing with the sum is that there's 2 formulas you can use. When it was just a series, there was the 1 formula. When there's the sum, there's 2 formulas. When do you use which is the catch. So this is the first one. Sn represents the sum of the first n terms. So sum. Then you have n divided by 2. N is still the number of terms. T1 is still the first term. D is still the common difference. Nothing changed there. The only thing that really changed was the Sn, right? But that's just sum. You use this formula when you're given the first term and the common difference. First term and common difference. Okay? The variation of this formula comes from by substituting Tn in. Okay? So when you substitute Tn in, you're going to get all this lovely formula, which is great. You will never be asked to reproduce that. But it does show you that you can get another form of it. So this is the other form you can have, and you'll be given both. Sn equals n over 2, t1 plus tn. Now this one looks a heck of a lot easier than the other one, right? The catch is that you can't use either of them all the time. You have to use each of them depending on what you're given. So the last one, if you're given the common difference, basically you're going to use this one. If you're given the last term, you're going to use this one. So if you're given the last term of the series, like this plus this plus this, dot, 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 plus 200, let's say, then you're going to use this formula because you're given the last term, the nth term. Okay? So when you're given the nth term, when you're given Tn, you use this one. Both of them have T1 in them. The only difference is if you're given the common difference, you use the top one, and if you're given Tn or the last term, you use the bottom one. Okay? The big thing about both of these is that people think, okay, these lessons aren't connected. This is a series question. I given 2 new formulas. That last one was a sequence question. I was given 1 formula. They don't correlate. However, they do. Both of these formulas use n. Both of these formulas use n. You need to know the number of terms always in order to use either formula. You always need to know the number of terms. So if I give you 1 plus 3 plus 5 plus dot, 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 101, and I ask you to tell me the sum of that series, you're going to need to know n. I didn't tell you n. How can you find n? Using yesterday's formula. Then you'll solve for n, because you'd know the common difference, you'd know the last term, you'd know the first term, the only thing you didn't know was n. So if ever you're not given n, and I'd write this at the top because you don't have space at the bottom. If not given n, use that formula to solve for n. That's where everyone gets stuck because they're like, I can't use the formula as either of them because I don't have n. Then you have to use yesterday's formula, okay, to solve for n. So they are connected, the 2 days. When you're done writing that down, flip over to the next page. So this one here says, find the sum of the first 60 terms. So they give me n. Yay, I don't have to find it. Okay? So we know n equals 60. Now our biggest issue is to figure out which sum formula do I use. Do I use the first one where I'm given the common difference? Or do I use the last one where I'm given the last term? Which am I given here? The common difference or the last term? Taylor? The common difference. So I'm going to use that very first formula, right? The uglier one, nonetheless, but still the first one. So the common difference is 8 minus 5, or 3. I still know T1. It's 5. And they want me to find Sn, which is S60. If I know everything else, I can use the formula, because I can only be missing one thing in order to solve, unless it's general term, right? So the formula is Sn equals n divided by 2, 2t1 plus n minus 1d. So we fill in what we know. S60, because we're finding the sum of the first 60 terms. That's what S60 stands for. 60 divided by 2. 2 times T1, T1 is 5, plus 60 minus 1, and D we know is 3. Please don't try and plug this all in at once into your calculator. 60 divided by 2 is 30. 10 plus, and then this is going to be 59 times 3, just like we did in the last day, right? And 59 times 3 is 177. So technically we're going to get 30 S60. equals 30 times 187, which is 5,610. Now we should always ask ourselves, does it make sense? So the first three terms themselves, 5, 8, and 11, adds to 24. Okay? The first 60, do you think that it'll get that big, that it would add up that fast? Once you get to the 60th term, it's going to be a pretty big term already, right? Because 11, then you're going to have 3 more is 14, then 17. So it's starting to get big fast. So 5,610 sounds reasonable. If you get like a million or something, it's not going up by that fast. When we do sum of geometric grows really fast because we're going to be multiplying and dividing. So if you get something big when you sum a geometric, understandable. If you get something kind of big when you sum an arithmetic, it makes sense. Okay, so you have to see, does it make sense? You guys try B. So you get negative 3,900. Does negative make sense? That it needs to sum to a negative number? Yeah, all the numbers are getting to become bigger negative numbers, so your sum is going to be negative, right? Sometimes when it starts off with like a lot of positives, but then ends up turning into negatives, like say it starts at 100, but it has a common difference of -3. Sometimes your sums will be super small then, right? Because the positives will cancel out all the negatives. So it depends on what you're dealing with. Okay, let's look at this one. This one says, find the sums of the arithmetic series 5 plus 9 plus 13 plus 201. Everyone gets super excited. They say, okay, I know the first term and I know the last term. So you can use the first term and the last term, right? So it's the smaller formula you can use. You could use the other one because you still do know the common difference. What's the only catch here? Taylor? You don't have n. So we need to find the number of terms first, okay? So we need to use the Tn equals T1 plus n minus 1d formula to find n. Okay? What's Tn in this case? Cody. What's the 201? Yeah. And Christina, what's T1? Right. N minus 1, because we're trying to find n. And what's d, Cole? Yeah, 9 minus 5, which is 4. So we get 201 equals 5 plus 4n minus 4. We get 201 equals 5 minus 4, which is 1 plus 4n. Move the 1 over by subtracting it, and they get 200 equals 4n. Divide by 4, and you should get 50. Yeah. So now we know n is 50, and we can find the sum. It's better to use, you could use either of them because you do know d, so you can use the first one. However, the second one is simpler, so why not? So Sn equals n over 2 t1 plus tn. So we're going to get S50 equals 50 divided by 2, T1, which is 5, plus Tn, which is 201. So it's 25 times 206, which is 5,150. Oh, look, a similar question just set up for you to do. So we have T1 equals 6, D equals 12 minus 6, or 6. Tn equals 150, and we have to solve for n first. So we're going to go Tn equals T1 plus n minus 1d. Tn is 150 equals T1, which is 6, plus n minus 1, and d is 6. 150 equals 6 plus 6n minus 6. Let's cancel. So I get 150 divided by 6. Is that 25? Yeah, you had said it was 25. And then we can use the short formula 1 because we know the last term and the first term. So S25 equals 25 divided by 2. T1 is 6 plus Tn is 150. 25 divided by 2 is 12.5 times 156. I don't know what that is. What's 12.5? 1,950. So the sum of those 25 terms, 1,950. Doesn't make sense. My last term is 150. So yeah. Yeah. Yes. So we're going to finish the rest of the lesson tomorrow. I want you to do the homework numbers 1 to 3. At the back of this assignment, it tells you what page it is. I want you to just do the numbers 1 to 3. And I'm being nice. It's at the very back of the booklet. 1 to 3, I'm being nice because you need to finish the stuff from tomorrow. So if you're someone who didn't do your homework from tomorrow or didn't finish your homework from tomorrow, make sure you do. Because even if you do just the first little parts at the beginning, you need to be able to do the word problems that I assigned at the end, right? Because your test will have word problems on it.